I want to take a look at a problem in the context of an exam that talks about this two-way analysis of variance. Okay, so does the effect of one factor depend on the level of another factor? This is a question where there's interaction between the factors, and then if you are able to eliminate the interaction terms, then you can say, okay, is there a main effect for factor 1, and maybe is there an effect on factor 2, and that's talking about the main effects. Let's talk a little bit about a particular example that might relate this to it. Okay, so this was an observational study from Harris Bank from 1969 to 1977. So the motivation of this is to see whether there's evidence of gender inequities. Okay, so the response variable, LN basic salary, bank salaries, is just sort of a transformation of the data. It's a natural logarithm of the starting salaries of employees at the bank. The reason why you do that, remember, is that you might have data that's exponentially distributed, and if you take the natural log, if it's exponentially distributed, then it'll become a linear function. So, okay, so let's say that this was happening today, and you were trying to say, hey, there is gender inequities in our firm. Well, you could say, okay, so what might you say? Well, there's just people that have been here longer, and maybe that was the inequity because before, now we're living in a post-gender society. So one factor might be if you're male or female. The other thing might be age. You know, longer you've worked here, you might get more promotions and all. Or maybe the education could be it, because maybe people who are more educated should actually earn more money. And again, the same sort of thing with experience in months prior to working at the bank. So the more experience, you might start off at a higher salary. And then, so it may be, maybe it's age, but maybe older males could have maybe higher salaries, or educated males. So it may not be at the lower level of the bank, like the bank tellers. Maybe they're all making the same money, but maybe males who have a higher education might have a higher salary or than males in experiences. So these are the type of interactions. You could say, well, you just can't compare male and females. Maybe you need to look at their education or experience to determine how their salaries vary. So let's take a look at the computer output. It says the computer output is more than enough information to answer the questions. Again, we should go through and check the assumptions, residual analysis to check. So it says it's okay. And every regression includes the predictor senior. The reason is that the employees were hired at different dates, and including senior serves to make an adjustment for inflation so that the beginning of their salaries is a fair comparison. Okay, so let's first of all answer the first question is, what would it mean if there's interaction between gender, that is male, and the predictor variable's education? So one thing you want to do before you kind of get too far in is kind of make sure which ones are categorical data and which ones are quantitative data. So time in months, that's quantitative. Male, either male or female, so it's categorical. Age, I suppose in months, we'll say that's quantitative. I don't think we want to split it up into 144,000 different months. We'll say that same thing, education in years. Experience, again, that would be quantitative. And then you have male times age, these interaction terms that we talk about in the chapter on two-way analysis of variances on page 157 to 165. So that's one thing. We want to make sure that we know what type of data that we have. Now let's take a look at the data itself. You can see here that this is the natural log of the bank salaries, and here's the senior. Remember, this is the time in months that's employed by the bank, and then their sex, and males are coded as 1 and females are coded as 0. The age is in months, not in years. We have no Methuselahs at Harris Bank. And then the number of education is in years, so this person probably went 3 years to college. And then the experience in months is what they came before. Now, taking a look at the data, the blacks are the female. You can kind of see there's a lower trend for females. So seniors employed at the time of the bank, their bank salaries seem to be going down, whereas males seem to be a little constant. But you could say, well, that's just because the males that you have a higher educational experience. So this is, again, is a question about interaction. So now let's make sure that we understand the different models. This model includes everything. The kitchen sink has sex times age, sex times education, and sex times experience. So that seems to have a lot of interaction terms. Let's look at model 2. Those seem to have all of the predictors but none of the interaction terms. Model 3 looks like it got rid of age, education, and experience and just has senior and male. And model 4 has senior, age, education, experience, so it looks like it got rid of something else. Education. Well, one of those. You could kind of pair here again. Constant senior age, education, experience. Constant senior male. Okay, so it got rid of the gender part of that. So just kind of go through and take a look at what the models are, and those might help you because we have several different data here. We may not need all of that. But again, it says that the computer output is more than enough to answer the following questions. Well, the first one is, what would it mean if there is interaction between gender and the predictor variable education? So what you could say here is the effect of each other, or the effect of each depends on the level of the other. So the effect of education depends on the level, that is the male or female part of it. So you could even say the effect of education depends on the gender. And so let's take a look at a graph which illustrates how such an interaction might look. And so this is going back to our course pack, graph like this. Remember, there's no effect if these are parallel, and there might be an effect. You have to determine if it's statistically significant or not. Oh, I use that word. All right, so let's kind of take a look. The graph of natural log of the bank salary, and on this side we have education. And so what an interaction might look like is that maybe females might be constant and males might be not constant. So anything where the slope is drastically different, something like this, or even something like this, maybe they don't cross. So anything that how an interaction might look, you might just, because you're trying to prove a point, you might have them cross. That in this case, the bank salary does appear to have some effect, or the education may depend on whether you're a female and have lots of education or male and have lots of education. So in this case, it doesn't matter what females have in terms of education, their bank salaries are flat, whereas males might depend on their education part. So I'm going to pause it there and go to the next page on the next video.